Hello guys, this is the third part of video under analysis. So we spoke about the softwares to be used, paying attention to the type of outcomes, pooled outcomes that you are going to report in your meta-analysis, limitations, how to compare, etc. So in this video, I just wanted to highlight the statistics part. So statistics is definitely difficult, for majority of medical doctors like us, but it's always important to understand the various terms like odds ratio, risk ratio, relative risk, pooled percentages. How are they being compared? Is it a pairwise comparison? Regression analysis and the limitations of all these analysis. Many times we are all, obsessed with the p-value thing. There used to be a very nice video on Netflix about how this p-value came about, what's the underlying concept of p-value. It was a very nice video. I don't think it's on Netflix anymore, but I'm sure you might find it on YouTube. I can provide a link if I find it. I think it used to be called something about numbers, so I will look it up and I will put the link on forestplot.com, which mainly explains, how this whole p-value came into existence in statistics. The main bottom line was that the p-value really does not tell you that this is the rule or this is what you have to do. What it basically tells you is that that's an area for further research. The way they explain is we all take or treat p-value. If it is significant, then we all treat it as, okay, the judge has passed the rule. So that's really not the case. The area where p-value is significant tells the researchers or tells us that that's the particular situation that has to be brought to the court and has to be argued if that person has made a mistake or not. So it's not like passing the ruling that something has been committed or something is good or something is the treatment of choice. It's not. A p-value of significance tells you that in that particular or that particular variable or that particular concept, further or detailed research should go into that particular area. In terms of meta-analysis, the main statistics to report, apart from the pool rates, is prediction interval. If you are using the random effects model, the prediction interval tells you what is the range where your results would fall in the real world. I have a paper about how to read between numbers in heterogeneity, published in GI journal, and I have provided a link on forestplot.com, which kind of makes you understand, what is heterogeneity, what does I square mean, what is the meaning of a 95% prediction interval. I think that is a good paper to read and kind of make an understand. And I would definitely encourage you all to read that. Then comes meta regression. I honestly am not very strong with the meta regression concept, but it's basically a tool that tells you what variables or patient variables significantly contribute to the heterogeneity. It can also tell you what variable might be linked or related to the outcome in your study, but it's a kind of a weak statistics, in terms of regression, to really report on the effect of a variable on the outcome you see. And then comes the publication bias. It's like a one button click on CMA software. It gives you the funnel plot. It gives you the Edgar's regression value. Significant value means there is publication bias. Non-significance means there is no publication bias. Also, I would encourage to read about publication bias, the concept, how does the sample size and how does the effect size relate or come together to calculate a publication bias. It's all related to how big the sample of the study is or how small the sample of the study is and how big is the outcome or the result from that study. So those are the two main components that is used to come up with this idea of a publication bias. Sometimes we do studies on diagnostic accuracies. For example, I have multiple papers, like diagnostic accuracy of artificial intelligence on capsule endoscopy images, diagnostic accuracy of manual on-site evaluation or MOS in EUS-guided pancreatic biopsies. So in diagnostic accuracy studies, you are basically reporting sensitivity, specificity, positive predictive value, negative predictive value. So these kind of outcomes, they really don't fit in the model of sample size relating to your outcome size. So in those type of studies, a publication bias does not make any sense, in my opinion. At the same time, for each individual outcome that you are working on, let's say technical success, clinical success, adverse events, for each of those analysis, the software will give you a publication bias plot. So which ones do you use? So I usually go by the primary outcome ones. What was the initial study or the original study's goals? If their main goal was to report the clinical success of an intervention, then I use that pooled rate or pooled calculation sheet to calculate my publication bias. So I typically don't report publication bias for technical success, for clinical success, or adverse events. To me, it doesn't really make any sense. You can only have one publication bias for the whole study conceptually, right? So the primary outcome or the main outcome that is being reported, which has the maximum number of outcome values, that's included in a meta-analysis, analysis assessment, I usually use that to report the publication bias of my paper. So I think with this, I kind of basically, summarize the whole analysis area, statistics, understanding some of the basics of things, or at least as a medical doctor, some basics that you need to know and understand in a meta-analysis so that you can critically review and appraise your own study and report them in your limitations. Many times we don't have to go into the details of this statistical jargon. The readers, being medical professionals, may not be interested in those values, but definitely mention those, and in your conclusion use terms like it seems to be or it might be, and future studies are needed to kind of establish our findings. When you know conceptually that what your statistics is or what your pool rates are, they really don't change, or if they don't change any management, then use those suggestive terms than being more clear cut, like to to make a kind of a practice changing outcome, you need randomized control trials, big sample randomized control trials, well done randomized control trials. In all the other situations, you are basically suggesting what the results could be, and you are basically suggesting future ideas or future studies that need to be done to establish your finding. I'm sorry guys, this video has gone for almost 7.5 minutes, so I'll stop here. Thank you.